Welcome to this lecture. In the last lecture, we had looked at the proxy pattern. We said that it is a very useful pattern, very simple pattern, and a proxy has many different uses in an application. We had identified 7 or 8 very different uses, and then we were looking at the class structure of the proxy pattern. Now, let us continue from there and we will look at the different applications of the proxy. The class structure itself is very simple. The subject interface is implemented by the proxy and the real subject, and the proxy holds a reference to the real subject and delegates any method call that it cannot handle by itself. Now, let us look at the virtual proxy. Here the virtual proxy is a stand-in or it is a representative of the real object. The main motivation of the virtual proxy is to speed up an application. The way the application is speeded is that many of the high resolution images are very time consuming to load from the disk and display. If there are thousands of images like this, it will really slow down an application during its start. The image may be 2 MB to load, but then the proxy by itself may be just 2 KB or less. In many applications, as you will see now, that the complete image is not always necessary. We will just show the proxy to the client, to the user will see only this, and only when he is interested he will click on the proxy and then the real image will be shown. In the virtual proxy, if we try to understand, a text document has many images, and initially what will be shown in the text document is the proxy. The real image is a heavyweight object. The data for the image is residing on disk. If we are opening a text document having, let us say, 500 images, 500 high quality images, then once we load the text document, we open the text document, it will take long time and the user will really feel that the application is slow. And for that reason, most of the text editors, they use an image proxy where all the images are not loaded when the text document is opened. Only those which are in the visible area are loaded, and as the client moves across the document, those which come into the viewing area are loaded. If we can just represent a large document, a large text document, let us say this is a large text document and it has many different images here embedded inside it, high quality images. In the viewport or the window, only few images are viewable. This can be accommodated on one screen. For the ones which are not in the viewport or the screen, for those only the proxies exist. and here these are the real images that are loaded only when the client or the user sees this. If the client stops, just changes here or reads here and stops, these are never fetched from the disk. The application appears to be fast. I just drawn a small one. Imagine that it has some 200 pages, 200 like this. This is one page, 200 like this, and just one page is loaded. The client or the user at any time might just look at only 3-4 pages. So, only those images are loaded, and as the client changes a page, the proxy here they determine that it is become visible and they load the real image from the disk. If we have to draw the class structure for the virtual proxy, it is the same one. The image is the interface. It has a bounding box and draw methods. The bounding box method is necessary to determine whether it is visible. Even if part of the image becomes visible, the image needs to be loaded. The proxy method, the proxy and the real image both implement the bounding box and the draw. The proxy holds a reference to the real subject. If the image is not loaded and it has become in the screen that is being viewed, then it loads that, and any method invocation is passed to the real image. But if the real image is not loaded, just the proxy exists, the proxy may be a gray rectangle. Initially, as you change the page, you might just find a gray rectangle until the proxy gets loaded, because the proxy may take some time. They are heavyweight objects. You can see such a situation in many of the word processors. As you change the page, you might find that initially some of the images appear as gray boxes or gray rectangles, and those are the proxy, and they are trying to load the real image because it has become viewable, and as soon as the real image is loaded, you can see the real image. Now, let us look at an application, the picture viewer. This is a photo album, where there is a photo album application where we can store many high quality images, maybe 10,000 images can be stored. In a very naive application where the proxy pattern is not used, as you start the photo album application, all the images that have been stored in the photo album will get loaded, and it will take 10 minutes to open such an application. But all the users want the application to open very fast, and therefore, only the proxy is shown. We will see the picture in the next slide. We do not load all the images at the start, and in any case all the pictures are not viewable in the display window. As the client requests an image, the image is loaded. So, these are all proxies. There are many pictures here, and let us say one of the picture is shown here. high quality picture, 100 initially we can at most show one picture at a time, and therefore, the application start only one of the picture is set, that is loaded, and as the client, the user selects one of these, then a different picture will be loaded. Those are not loaded, the start loaded on demand. So, this is an example application of the virtual proxy. Now, let us look at the code for that. The image interface implemented by the proxy image and real image. Proxy image holds a reference to the real image and delegates when necessary. This is the code for the interface. Public interface image, public void display image. So, this is the code for the image, public interface image, and this is the method, and this method will be implemented by the real image and the proxy image. In the virtual proxy, the main idea is lazy loading. In a word processor, the text document contains lots of multimedia objects, and these objects can be images, movies, etc., and these will be loaded only when required. Initially, the proxies are shown, and when these become visible, the client first time opens a page and the page becomes visible, those are loaded. And if the client never looks at a page, those images are never fetched from the disk and never created, and the overhead is never incurred. Let us say we have a text document with 10,000 pages, and at one time the user looks at only 5-7 pages, then just imagine how much faster it will be with the proxy. As we are mentioning, sometimes the proxy might implement some of the operations itself, and here as the client invokes those methods which the proxy can answer satisfactorily, it does not delegate to the real object. And the proxy stores the necessary information to create the server object on the fly, for example, the file name or the network access address if it resides across the network. This is the code example. Let us say we have this graphic, the document editor invokes the graphic depending on whether it becomes visible, and the image and the image proxy both implement the graphic methods here: draw, get extent, store and load. And if the image is not loaded, then it loads the image, and if the image is 0, if the get extent method here, if the image is not loaded. So, this is the get extent method here. If the image is not loaded, it returns the extent that it stores, otherwise this is the approximate extent that it stores, and if the image is loaded, then it calls the method image.getExtent. Now, this is the rest of the code. Graphic is the interface, and this is the display image and load image. I have just written two of the methods, display image and load image. And the image implements graphic, image is, has the file name, and the file name is created in the constructor, and then the display image just prints the file name. It is a simple implementation of the image. Now, the image proxy also implements graphic, and it has a reference to the image here, as you can see. It has a reference to the real image, and the image proxy, it takes as argument, the constructor takes argument the file name and stores the file name, and then if the image has not been created and the display image is called on the proxy, then only if it is not created, it creates the real image and then calls the display image and the image, real image. Now, this is the client. It has many images, just written here array list images, and then many images are added here, 3 images, photo 1, photo 2, photo 3, and then on the array list we just access the objects at 0, 1 and 0, and then we can call the display image or the load image, and these are just the proxy here. Just look at here that actually the array list is images, but then it contains only the proxy, and only when needed the actual image will be loaded and displayed. Now, let us look at a second application. This is a remote proxy. Here the proxy is a local sit-in for the real server object. The client thinks that the server is available on the same machine, but actually the only proxy is there on the same machine. The server is across the internet somewhere. The client interacts with the proxy thinking that the real server is there on that machine. The client thinks that the proxy itself is the real server, but then as the client requests the proxy tries to handle some of the request if it can. Otherwise, it assembles the data or the request into a network message and then sends it to the remote object, which is the server, and then the server processes it, returns it to the proxy, maybe compresses this, maybe a large data, and then the proxy receives the compressed data, decompresses and then returns it to the client. Simplifies the application development, that is the client code. It need not get bogged down with the server address, contacting the server, instantiating and so on. All these responsibilities are taken over by the proxy. The proxy also handles many messages. It can and does not unduly overload the server, and also speeds up the response to the client. It delegates messages to the real object when necessary. So, this is the remote proxy structure. the server or the supplier interface and then implemented by the proxy and the real server. The client interacts only with the proxy which is there on the same machine. The client creates the proxy. The proxy holds the reference to the real server, the address on the network, and it can create the network over the network if the real server does not exist. Otherwise, if it exists, it just invokes the method when it cannot handle by itself. If we look at the proxy behavior in the form of a sequence diagram, the three classes that are involved are the client, the proxy and the real server. The client interacts only with the proxy, and some of the requests the proxy handles here does not even pass on to the real supplier, and some requests it does some work here and then creates a appropriate method on the real supplier, get the data, any further processing required might do and return the data to the client. The Java makes use of the Java collection classes make use of the proxy pattern. For example, the read only collections or the synchronized collections. In the read only collections, when we want some collection object to be only read only, the clients cannot make any changes to this kind of data. We want some data to be only read only access to the client objects, they cannot modify it. Then a proxy is given to the client. The proxy is created, as you can see here. This is how the read only collections work. Collections dot unmodifiable list, and the argument given is the list. So, this is the ID of the actual list, and the unmodifiable list is the proxy which holds the ID of the actual list, and it has additional code here. If the client requests to write, it throws an exception. Otherwise, if there is a read request, it just passes it onto the list. The synchronized collections also use a proxy. The synchronized collection is a proxy. Here again, when many objects tries to access a object, the proxy synchronizes the access, it acquires a lock before calling the method, and if the lock is not available, it does not make the call. The client objects wait, and only when the lock is available, it calls the method, and after the method results return, it releases the lock, and therefore, the server has sequential. At any time, only one of the clients can make a call to the server object, and that discipline is enforced in the synchronized collection. And here the code is that the client deals with only the proxy, the list is given as an argument in the constructor, and the client deals with only the proxy. There are other uses of proxy. Proxy has large number of uses: copy on write, multiple clients share the same object, and therefore, it is not necessary to create many instances of the object. helps to speed up the application. But if one of the client tries to modify the object, then a copy of that is created, and the client who modifies uses the copy that has been specifically created for that client. The other clients continue to share the same object, and here it speeds up the application by maximizing resource sharing while making it look like everyone has its own object. Optimized string classes use this approach. The clients are given proxies rather than direct references to the object, and only when the client tries to write, the proxy creates a copy of the string object and gives it to the client. So, this is a representation of the copy and write. Just see here that before any write, the clients are sharing the same object, they are just reading, and the proxy, through the proxy they access the real subject. But when one of the client wants to write, it has got its own object. So, okay, proxy C wants to write, and therefore, it has got its own object, and the others are sharing the object. Similarly, reference counting, that is how many objects are now sharing an object. So, here the proxies maintain a reference, the reference count itself is inside the real subject. The proxies increase and decrease the reference count as a new proxy tries to access it. It first increases the count, and as it disconnects, it decreases the count. The last proxy, if the proxy is already 1, then before going it may delete the object. In the final analysis, we saw that proxy has many applications. It decouples the client from the server, but then it introduces a level of indirection. It differs from the adapter in that it uses the same interface of the server object, whereas the adapter the proxy has the same interface as the real object. There are related pattern. The adapter provides different interface to an object. As we have already seen, an adapter changes the interface to a different interface, and we will look at the decorator pattern in the next lecture. It is also similar to the proxy pattern, but for different purpose. Decorator is a very powerful pattern. Here we can add responsibilities, whereas the proxy controls access to the object. As we look at the decorator in the next lecture, this aspect will be clear. We are already at the end of this lecture. We will stop here and continue in the next lecture. Thank you.